Thanks, everybody. Can you hear me? Okay, great. So this talk is going to be about how can you use eBPF to enhance your observability of your service mesh. What I want to cover today, it's a lightning talk, 17 minutes. I want to cover, first, why would you want to even monitor your systems? I want to give you a short intro into statistics in Envoy, 3 gaps that you might have when you use that kind of Envoy visibility. Then how do you fill this with flow data, talk very briefly about BPF, and then give 2 examples of production outages that this kind of system would have, the visibility that it would have given you. Then if we have time, I'll go to how do you productionize such a system to get eBPF data. So first, I'm Jonathan Perry, a little bit of history. I started my career in an Israeli government technology research and development unit where I was exposed to large-scale operational problems. 2007 to 2010, when my last role in that unit, I started a project in monitoring these environments and then automatically and semi-automatically reacting to failure, just to reduce the amount of time people spend. We had 10 to 20 people waste their nights on this. I then moved to MIT to do a PhD in how do you get these systems, these monitoring systems and automatic mitigation, very fine-grained, low overhead, low latency. So that's my background, and let's jump right in. So first, why would you even want to monitor a service mesh, the flow of data between your services? So the first thing, and that's what most people care about, is service health. How do I find out if I have a deployment or something happened in my system, which services are impacted, where should I look, and find, kind of first get alerted and then also drill down into what happened. Other use cases, and these are general categories, are understanding the architecture of the system so that you can train new people in operating it, auditing your high availability architecture, seeing if you have traffic between clusters that shouldn't have, maybe dependency between production and staging. I know most of you think that it's impossible, but we have seen it in some places. And then lastly, audit cost. When you're on the public cloud or even on-prem deployments, traffic going outside clusters is expensive. You have to pay for it either with dollars or with limited bandwidth that you have in your cluster. So how do you optimize that traffic? So now let's jump into how Envoy observability works. And here I'm focusing only on the observability part and only on statistics. There are a couple more mechanisms. Istio has Mixer, but I'm going to focus only on the statistics mechanism. So you have a service and an Envoy proxy. And the 2 components where traffic pass through are the HTTP connection manager and the cluster. So that's like incoming connections and outgoing connections. You can think about it downstream and upstream. Very frequently, when you have a big deployment, you have Envoy on both sides. So you see both of these, you hit 2 sets of these components. What statistics in Envoy, the statistics mechanism in Envoy gives you are these aggregate statistics, first on each upstream cluster and on each HTTP connection manager. And those are aggregate statistics. And they're good in most cases. They're great, but I'm going to talk about a few gaps in this model. This is the important thing to take from this slide. You have these aggregate statistics going out of an Envoy to an upstream cluster and coming into a cluster. I put in the different types of metrics that you get from these components. I don't want to cover them now. If you want the slides, I'm happy to release them. So what are some gaps you might experience? And I'm going to go through each one in more detail. First, what happens if you don't have amazing coverage for your service mesh? What if you have managed services that you cannot deploy to, or if you have incremental deployments? The other one is what I call checks and balances. Kind of how do you verify your own configuration and make sure that your telemetry doesn't lie to you if other parts of the system lie to you too? And the last part is how do you know, kind of once you know that there's a problem, how do you know if it's in the infrastructure or in the application? I'll cover these. Let me go through these very quickly. It is a lightning talk. I hope I'm not talking too quickly. So first gap, how do you handle managed services and partial coverage? So in this case, you have your service, you have your Envoy proxy, and the upstream service that you're accessing might be external to you or not instrumented. So for example, this could be your RDS database, or you're using Kinesis for message queues. You're using a credit card processor, or sending email via API or text messages and so on. We had AI companies use AI services, external services. What do you do then? You get aggregate statistics from the Envoy side, but you don't get very detailed statistics on the service side that would help you debug with your provider. And this is where you really need the data, because it's not the same organization, and they think you're just wasting their time. You really need actionable data. And this pattern is more general, where you can have your legacy services internally that want to access Envoy services. Maybe you have an ECS deployment and a Kubernetes deployment. The Kubernetes, you've rolled out service mesh, but not on your ECS deployment, that sort of thing, incremental deployment things. And maybe sometimes you have two legacy services that are not covered. So this is one gap you might want to fill. Second gap, what I call checks and balances. So I've put configuration for an upstream cluster that has a problem where this could be a human error. I think maybe Istio helps with a lot of these things, but there are, you wouldn't have exactly this type of error, but this class of errors where you thought you were configuring a customer database, but you ended up pointing it to a product database. So, or you thought you were hooking up components that are from your production environment, but you have a dependency on your staging environment. That sort of thing. Those shouldn't happen, but now if your telemetry system works off of the same configuration as your service mesh configuration, how do you you're going to see your telemetry is going to tell you that everything's fine, it's going to the right endpoint, but it's actually not going to the right endpoint. So can you have another layer of verification on top of that? And the third thing is, once you've had an error, and we've seen companies and users have this a lot, how do you know what really went wrong? Is it the application? So did you misconfigure your application? Did somebody introduce a bug or incompatibility into the version? Did they misconfigure Envoy or service mesh? Or is it capacity issue? On the one hand, application issues. Others are infrastructure issues. Is if you're on Amazon, is Amazon delivering the packets correctly? So the network routed correctly? Is DNS working? Is there rate limiting on your instance, on your VM that's happening? And so on and so on. And how can you tell? You can spin a lot of cycles pursuing the wrong problem. I'm going to tell you a little bit about getting some flow data from the Linux operating system. So let's say you have this pod running in Kubernetes, and it has the service and the Envoy service mesh as a sidecar. First, you can contact your Kubernetes API endpoint and get information about that pod. And here I've highlighted the IP address for the pod, the name of the pod, and the container IDs. And now you can go on that machine, extract information from the kernel, here using the SS tool to look at the sockets. And here you can see the IP addresses that are communicating, my IP address, the A side, the other side, and how many bytes were sent, and other very useful telemetry like round trip times, packet drops, and so on. And with this data, you can see how you can assemble it. If you have a system to process this from both sides, match the container information, you can get very good information about how your system is behaving. Usually you wouldn't want to use these command line tools. You would want to have some way to stream updates from the system you're measuring, because polling is expensive. You have to go through a lot of these data structures. So the kernel has to go through a lot of data structures to look at every single socket, but maybe only 2 sockets were active the last second. You might miss some data, so you want to get these stream of updates. And BPF is a system, a subsystem in the kernel that allows you to do this. It's an API call in the Linux kernel was around since 3.18. What it basically allows you is to run a snippet of your own code inside the kernel upon almost any function execution inside the kernel. Very safely and in a high-performance way. The bonus is, like I said, you get streaming data. So every time a new socket communicates, you can get an event there, and you don't have to go through every socket in the system. It's very safe. It's built to to not crash your kernel ever. So it has an in-kernel verifier that makes sure you don't don't access invalid memory. And in the context that we're talking about, everything is read-only, so you cannot affect the kernel's behavior other than performance-wise. And performance-wise, it's very fast. It's just-in-time compiled into machine code. So you could write very low overhead instrumentation. This means that you can get 100% coverage into everything. You don't need to deploy Envoy, you don't need to change your applications. And with extremely low overhead if you know what you're doing. And this is amazing, right? It's like you just deploy it, you deploy this agent on the system, and you get visibility into whatever's going on. Very low friction. So at this point, I want to go through a couple of examples of data that the system can flesh out that you wouldn't necessarily get from a service mesh. So last year, there was a big DNS outage. And here, I hope this is not as visible. Let me switch to the screen. So you can see measurements from US East 1B. Everything was fine. What you can see here is the number of UDP packets to the DNS server and number of packets going back. So you have these two lines here. US East 1D, everything's fine. And then US East 1E, something went wrong. The DNS resolver just didn't work. So you had these retransmissions, and you can very quickly see it from these very simple metrics that you get from the operating system, right? The requests jumped by 2x, and the responses stayed the same, so it means that you had retransmissions on almost every request. So here's something that kind of lower level information can give you. This is the infrastructure level information. This is about infrastructure versus application. Another one is use of external services. This is the second example out of 2, so we're close to done. I know it's a marathon, so here there was a system that used Kinesis very heavily, read from these message queues very heavily, 800 megabytes a second, multiple instances, and it had a dramatic outage one morning. Our users try to understand what is it. So first question is it my application? Is it limited to one availability zone? So you could look at the user's traffic, how the different availability zones that are running our user's service behave. They all behave the same. They all had the same drop around the same time. Now the question is this specific to a Kinesis instance or a bunch of instances of Kinesis? So can we help Amazon debug this by telling them, okay, it's these IP addresses, maybe they have a locality sort of problem. And here you can see, well, let me zoom in a bit. Well, you know what? What I'm going to do is I already prepared this. So this tells you that all the instances behave similarly. Right, you can see all the instances. There's a list of all these instances. There are maybe 60 instances. They all behave the same. But at least this is actionable data that you can first you know this is probably not your fault. This is something that the system is behaving, and you can come to your provider and tell them, this is how your system is behaving. Can you help us out? Interestingly, this particular measurement also had a smoking gun. I'm going to show you, this is a more advanced usage, but we're thinking about constructing filters to automatically compute this. So this is, I'll go back here. I'll show it here, it's fine. What you can see here is the throughput drop. Next to it, you can look at TCP drops. TCP drops didn't change dramatically. So there are these spikes, like one connection had these high packet drops. So usually it's 0.1%. If I zoomed in a little bit more, you could see very negligible drops. So the problem is not a networking problem. But round trip time increased dramatically. It was maybe a few microseconds, right? 6 microseconds. It increased dramatically to these hundreds of milliseconds. And apparently there's a paper and here I have the citation, research by Microsoft. It's on the top there. Research by Microsoft showing exactly this, that if you collect this telemetry and you show that there's no increase in drops, but there is an increase in round trip time, it indicates that the CPU on the other end is exhausted. So here there was a smoking gun saying, here, your provider going to Amazon and saying, here, you have CPU exhaustion on your instances. That this is something that you just wouldn't have gotten if you hadn't collected these lower level metrics on the infrastructure. So managed services and infrastructure. I don't have auditability here. Let me talk very briefly about kind of what it takes to productionize it. If you want to build such a system, I'd love to talk to you and love to help you out. We've been doing this, so these are kind of a couple of emphasis points on how to do this. First, with BPF code, make sure that you don't get called too much in the kernel. It is super efficient, but you don't want to put it on. You don't want to do work on every packet, for example. So kind of you profile and iterate. It's not. You can do it. We've been able to get to 0.1% CPU overhead on these systems. The other thing is watch out for network overhead. We've had kind of our initial prototypes had very high throughput overhead. So any system that kind of you should ask kind of if you're going to use something like this. Like I haven't worked with Mixer, but ask what the network overhead of this. You can work around it. So we kind of by encoding efficiently and compressing, you can get the overhead down. We have under 1% network overhead. Security, kind of how do you secure the system? This is if you're running a production service, you know how to do. And then try not to batch. This is kind of what we've learned. We initially built a batch system, but then we realized you really want to stream this. You want to stream this with low latency because you want to, when event happens, you want to see it maybe within 1-2 seconds on your dashboard. So do that. There are a couple of other points you want to take care of, and this relates to analyzing the kind of a big amount of data that you're going to have with a service mesh anyway. So how do you you need to balance the query time with the ingest time. So you don't want to have queries that have to look at 1 billion events when you serve data. So kind of pre-aggregate, there are a few tricks you can do there. And then kind of the alerting solution, I think with, it's very easy with Envoy to get data out, but there's no kind of handbook on how to build alerting on top. So you have to custom build that. There's no system. So if you're interested in any of these topics and this sounds interesting, I'd love to talk to you later. Also my contact details are on the slide. And I think we have 1-2 minutes for questions. So thanks.
Can they be plugged into the Mixer framework?
Yes. So one of the things you would want to do with one thing you want to do with BPF is have another dimension of collection. So you want to collect more metrics that are network layer. The other thing is analyzing this data and the commonalities between analyzing BPF data and analyzing Mixer data. There's huge overlap.